Okay, so what I want to do is skip example 1 for now, and I want to just go to example 2. Okay, so if you take a look at this right here, it says given f of x equals 1 over x, find 2 times the quantity f of x. So basically what we're going to do is we're just going to take 2 multiplied by 1 over x, and that's going to give us the result, 2 divided by x. Okay, so all we're doing is taking the parent function and multiplying by 2. That transformation, that's just a stretch, that's all that is. Okay, and I'm going to go through all of the domain, the range, the end behavior. I'll show you what all this stuff means in a second. But what I want to do is just go back to the graphing calculator and just add to y2. We're just going to do 2 over x. 2 divided by x. And then we'll graph it. And what's nice about the TI-84 plus CE is that our original function 1 over x, which was y1, that's in this blue color, and then the 2 over x, that's in the red color. Okay, so it's just being stretched. You can take a look at the table to compare the y values. So remember what we're doing with the y values, we're just like multiplying them by 2. So easy one to look at, when x is negative 1, the output y1 for 1 over x is negative 1. Multiply that by 2, you get negative 2. Okay, and of course we're still going to have, if we put 0 in the denominator, we'll get arrows in both cases, total errors. Alright, so basically if we go back here, the asymptotes, the vertical and the horizontal asymptotes, they're depending on if there's a movement to the left or if there's a movement to the right. Okay, so since there's no transformations but just a stretch, the vertical and the horizontal asymptote, they don't change. Okay, so it's the same as the parent function. So if it's just a stretch, vertical and horizontal asymptote still stays at x equals 0 for the vertical line. Horizontal still stays at y equals 0. Okay, so I already drew the fun little curves in, the hyperbolas, to form those. Alright, and then so let's take a look at the domain, because this is a little bit new notation. Alright, so the x values, if you look at the x values, remember you're looking at from the left. So we're going to start off at negative infinity. We're going to actually stop at this vertical asymptote. So we're stopping at 0. So that's negative infinity to 0. But then we start back up again at 0. And then we're going to go on forever and ever to positive infinity. So we have that here. Okay? And where you're using parentheses, because remember, we don't ever touch 0. So you have to use parentheses, can't use bracket. And just to put these together, that's where you use that union sign. So you're just going to throw the u in between them. And the range is very similar. So when you look at the range, basically, you're looking from down below, and then you go from below to the top. Okay, so here, the y values come from negative infinity right here. They're going to stop at 0, the horizontal asymptote. And then we're just going to start back up. We'll start it back up at 0 and go on forever and ever to infinity. Again, we want to use the parentheses and not brackets, because the 0 is an asymptote. Remember, the graph's never going to touch that. Okay, so we'll get more examples of the range. So if you don't feel comfortable with that right now, don't worry about it, because we'll change it up so that's not zeros in both cases. But for the end behavior, when x approaches infinity, you are filling in, you're basically telling me what happens to y. So as the x values increase, the y values that they're getting close to would be 0. Okay, so you're basically going to be your horizontal asymptote. And so when those x values get smaller, which is over here, going towards the left, same thing's happening. They're approaching y equals 0. So basically, that's example 2. Kind of wanted to go over that first before we start moving things around. So yeah, that's example 2.